Howdy folks. So we're continuing on through this review pre-work, and I've asked you to work these problems here, and I've told you that there are hyperlinked solutions. So please try the problem. It is essential that you work through the problem as best you can, come up with what you think the answer is before you click the solution link. I do want to point something out on these solutions, and that is that as you're working through these, I went ahead and gave the answer many different ways. I did say in the directions do not simplify, so you do not need to do these simplification steps. But go ahead and give it a try, see if you can follow along the simplification steps that I gave. But again, for me, the most important thing is being able to do the calculus step at this point. And then if you want to keep practicing the simplification, but this would have been, and whenever I put those double underline marks, that would have been a sufficient place to leave your answer. Okay, so let's go ahead and jump into page 3 then of this handout. We're looking at page 3 here, and we're tasked with computing the derivative of this fairly complicated function here. In this case, our function is the secant to the 4th power of x to the 7th, and we are asked to find h prime of x here. Now, we could jump into this right away, but one thing that I found has been helpful for students over the years, because this is a problem that I feel very strongly about, we should be able to work this problem, is that we use this notation, secant to the 4th. Let me just note it, like if I were to say cosine squared of x, what I really mean is cosine of x times cosine of x, and that would be the same thing as writing cosine of x quantity squared. So I really wish math people, instead of writing cosine squared of x like that, it saves a little bit of space. It's kind of hard to tell that, but if you were a typesetter and you were typing up a whole math book, you would save a lot of space if you wrote your squareds like this, as opposed to putting these big clunky brackets around it and then squared. However, what I've found for students is they find it confusing to figure out what the inner and outer function are. So remember, when we're doing the chain rule, it's important to identify the inner and outer function. And in this case, we actually have a double chain rule that has to be done here because we have a total of 3 nested functions. So to help us see that, the first thing I'm going to do is, although this notation is perfectly fine and you will see me use it and your book will use it, I encourage you to rewrite the expression this way until you're 100% comfortable with this notation. So I'm going to rewrite h of x as the secant of x to the 7th, and then I'm going to raise all of that to the 4th power. This expression is identical to this one, but here I think it's easier to see the nested functions. So let's go ahead and give this a shot. Again, before I do the derivative, let's do just a little bit of reorganizing here. And this actually isn't going to be any rearranging. What I'd like to do is I'd like to make it a little bit clear what my outer, inner, and middle functions are for this problem. So I'm going to rewrite this problem this way. Let's see, we need one more color. I guess we'll go with orange, x to the 7th. So here you can hopefully see the 3 nested functions that we have here. The outer function, and you don't need to identify these, you don't need to write them down, but the outer function would just be the function x to the 4th. It takes an expression, let's put it in blue here. The outer function would be just the function x to the 4th. It takes an expression and raises it to the 4th power. And the middle function would just be the secant of x function. And then the innermost function, in this case, is the function x to the 7th. And then hopefully you see that if I were to nest this function inside of here, and then nest this function inside of here, I would have the expression that we're working on. So that was a lot of preamble. Now let's go ahead and take the derivative. So if we want to compute h prime of x, by the chain rule, what we're going to do is we're just going to take the derivative of the outermost function, leaving that inside expression alone. And then we'll continue. So how do we take the derivative of something to the 4th power? It is that something now raised to the 3rd power. Okay. So how do we take the derivative of x to the 4th? It would be 4 times that expression cubed. That's how we've always taken the derivative of x to the 4th. So then we just simply copy in that inner expression that we had there. Now we're going to go ahead and then multiply this all by the derivative of that inner expression. So that's the key to the chain rule, is that you take the derivative of the outside piece, leaving the inside stuff alone, and then there's the operation multiply that by the derivative of what was inside there. So what was inside there, it was the secant of x to the 7th. Folks, you could certainly do this in one step, but I'm trying to emphasize the chain rule steps as we go through this. So then we go to we're going to keep computing h prime of x. So I'm just going to recopy down this line because I'm sort of already done taking the derivative of that outer piece. So we're just recopying that down. And this is where you could have done this in one step, although I don't recommend it until you're comfortable with it. Then now I'm going to start taking the derivative of the secant of x cubed. But notice that the secant of x cubed is itself a nested function. It's a composition of the function x to the 7th and secant x. I plug x to the 7th inside of secant x. So to take this derivative here, which is part of taking the larger derivative of h, to take this derivative right here, I have to do another chain rule. And the chain rule says we're going to take the derivative of the outermost function, leaving the inside function alone, and then multiply by the derivative of that inside function. So folks, what's the derivative of the secant of an expression? The derivative of the secant of an expression is the secant of that expression times the tangent of that expression. Then we're going to multiply that by the derivative of that inner expression. So what's the derivative of the secant of something? It's the secant of that something times the tangent of that something. But if the something that's sitting inside of the secant is more complicated than just an x, we need to adjust with the chain rule. And so we take the derivative of what's inside there. So in our case, the inner function is x to the 7th. So there it is. And then we're going to still have to take the derivative of x to the 7th by the chain rule. Okay? Notice that each time I induce a multiplication sign into this derivative problem, it's because I've done this chain rule here. So at this point, we've finished one chain rule, and we're in the process of completing the second chain rule. So folks, at this point, I just copy down what I've already got. So we've got the first line, which is 4, or the first factor, which is 4 secant of x to the 7th cubed. We did that by taking that derivative of the outer function first. Then we multiply that by the derivative of the secant of the inner function, or the middle function, I guess I should say. And notice that one thing that's kind of weird about secant's derivative, I specifically chose secant for this complicated expression because secant shows up in kind of weird places when you take its derivative. And I found that a little bit interesting. Anyway, there was our outside, derivative of the outside function, leaving the inside alone. Then there we had the derivative of that middle function, leaving the innermost function alone. And now we're ready to take the derivative of that innermost function, which would just be 7x to the 6th. Okay. I do want to warn you folks that if you do not need to simplify this, and I didn't really give you enough room to, I'm going to scrunch this up here. I didn't really give you enough room to simplify this, and I didn't ask you to simplify it. But if somebody were to simplify it for you, what would it look like? Well, notice that I have 4, and then how many factors of secant do I have? Well, here I've got 3 secants, and another secant. So I'm actually back to, let me put this all in a different, because I'm going to be just combining things here. 4, I've got this secant and this secant cubed and this secant. So I've actually got 4 secant to the 4th of x to the 7th times the tangent of x to the 7th times 7x to the 6th. And I could do some more cleaning up. For instance, I could do that 7 times 4, etc. So, there's some more cleaning up we could do. Let's do that. That'd be 28x to the 6th secant to the 4th of x to the 7th times the tangent of x to the 7th. That is definitely quite a mess to clean it up. And by the way, folks, I would have been perfectly happy parking your answer right here. It said do not simplify, and you've taken all the derivatives. But I just want to show you, if somebody said this was the answer, you'd have to compute the work on your own, maybe stopping here, but then recognize that you could get all the way to the end. So now we've worked through that problem, folks. I'm going to leave you to work the rest of these. Notice that I made number 4, and I just changed it to be very similar to the one that you just worked. So all you have to do is track the change in letters as you work through this, and I've given you a written solution that you can check your answers to. Okay. Then I'd like you to try number 5 here. 5 will be a little bit more challenging. We've got a square root in there. If you click the written solution, you'll see that what I did is I color-coded that. Let me pull that up for you. You'll see that I've color-coded that, and I think that that will help. We use the blue for the outside function, the red for the middle function, the green for the next middle function, and the purple for the innermost function. So you actually have a total of 3 chain rules that you'll be working through here. But notice that what I do is I just peel off one slice at a time. So we take the derivative of the outside piece, and then we've got times, and then this would be the derivative of that inner piece from the chain rule. But then we'll have to, when we take the derivative of this, we'll have to break it up into a chain rule and on down as we go through. So if that feels a little overwhelming, don't worry about it. Copy it, go slowly through it, and then let me know what your questions are. And then I've got one last question for you to work. This one will be a little bit longer again, but give it a shot. I think that you've got everything that you need to do it. And again, I have a answer to it, although the solution is not as detailed. Give it a shot, and I will see you guys tomorrow for our review day. Thank you very much.